So this is lesson 6.3c, trigonometric equations part 2. This is the third video, and we are on example number 3, and then we'll do 4, and then we'll be done with this lesson. Alright, so what we're doing here is we're taking 4 sine of theta times the cosine of theta, and we're setting that one equal to the square root of 3. Alright, so we have got a bunch of yucky stuff here. So what are we going to do with this? Well, this is where it's handy to have your notes with all of your cool little formulas, because we're going to use a formula clear back on page 213 in lesson 5.5. And that formula is the sine of 2a equals 2 sine of a cosine of a. So 2 times an angle is going to be 2 sine of that angle cosine of that angle. So that's what we're going to do here. We're going to look at this here, especially this here, and we're going to factor a 2 out. Okay? And when we factor that 2 out, look what we have. We have 2 sine of a, cosine of a, or in our case we have theta. So then we're going to replace this, because it equals that, with this. So we're going to rewrite that as 2 sine of 2 theta equals the square root of 3. Divide by 2, cancel. So I have the sine of 2 theta equals the square root of 3 over 2. That makes life look a little bit better. So what that says is that we have an angle, we multiply it by 2, and then we take the sine of it, and we're going to get the square root of 3 over 2. Okay, so this really helps me. Positive square root of 3 over 2, and we're talking about sine, so I know I'm going to be in the first 2 quadrants. So square root of 3 over 2. That would be the opposite over hypotenuse. So my hypotenuse is 2, my square root of 3 is here, which means this is going to be 1. And this angle right here is going to be a 60-degree angle. And because sine is also positive in the second quadrant, we have a 60-degree angle there, which means our reference angle is going to be 120. So the sine of 2 theta is a 60-degree angle in quadrant 1 and a 120-degree angle in quadrant 2. And let's look at something here again. Let's just do this in blue so you can get a better view of what I'm doing. If we go all the way around here again to here, we have 360 plus 60. So the sine of 2 theta is going to be also a 420-degree angle. And let's do this in red. If we go around this way, all the way around to this one again, we are at a 480-degree angle. So the weird part is, how many times do I go around? Well, the instructions say that our interval was 0 to 360 degrees. So that is saying that our theta can be a number, must be a number between 0 and 360. And these are not theta. 60, 120, 420, and 480 are not theta. Those are 2 theta. So if I take half of each one of these, then I get theta, because if this is 30, 2 theta is 60. If this is 60, then 2 theta would be 120, etc. So my sine, or I guess I should say just my theta, is going to be half of 60, half of 120, half of 420, and half of 480. So those would be my 4 thetas there, and they are between 0 and 360 degrees. So does that make sense how that worked? Because we're looking for, we talked about the sign being positive in the first and second quadrant, but then I've got a 210 degree angle, which is down here, and a 240 degree angle, which is also in this third quadrant. So it's like, how am I getting in the third quadrant? Well, we are looking at what theta is. We're looking up here at the first and second quadrant based on 2 theta. When we went to just theta, it doesn't matter what quadrant we're in. When we double it, we'll end up being where we need to be. Okay, so that's where we got sine of 2 theta is in the first or second quadrant. Theta can be anywhere we want, and then when we double it, we're going to end up in the second and third quadrant. So that's it for example 3. One more, example 4, and then we'll be done. Alright, this is example 4. 3x plus, tangent of 3x plus the secant of 3x equals 2. Alright, so what we're doing, we're solving. We're trying to find out what x is. Alright, so the tangent and the secant are related by an identity back in chapter 5, and that identity is 1 plus the tangent squared of theta equals secant squared of theta. So we're going to use that, and we are going to rewrite tangent of 3x plus secant of 3x equals 2, and we're going to get the tangent and the secant on opposite sides. Okay. Now I'm going to look at this formula I brought in here. See, I've got a tangent equals, and then I've got a secant over here. So I'm going to make a little bit of a switch. I'm going to write this as tangent squared theta. I'm going to take away 1 from both sides equals secant squared of theta minus 1. So now it looks a little bit closer to this. Only problem is, here I've got tangent squared and secant squared, and here I don't. So if I squared both sides, then I have tangent squared theta, or in this case 3x, and then I'm going to use the FOIL method. In fact, let's do this. I'm going to do it and then erase it. 2 minus secant 3x times 2 minus secant 3x. And when I multiply those together, I get 4. I'm going to do the first term, doing the FOIL. And then I'm going to do the outside. And then the inside. Whoops, that should be a minus, shouldn't it? And then last, secant squared 3x. Okay, so I squared the secants. You don't square this number there. Alright, so then I can combine these two because they both have secant square 3x. So I've got 4 minus 4 secant 3x plus secant squared of 3x. Alright, so I end up with that. That does not look like a happy place. But one thing I do know, I've got a tangent squared of 3x, and that equals this. So I can get rid of my tangent here, and I can go with just secants, and that'll be glorious, right? Secant squared of theta minus 1 equals that. So now all I have are secants. I don't have any tangents left. Alright, so I guess that's not a theta, it's a 3x, isn't it? That's what theta is that 3x right there. Alright, now if you notice, I have a secant squared of 3x here and 1 here. Nothing's added, or nothing's multiplied or divided by it, they're added and subtracted, and when that happens they can go away. Because if you were to subtract it from both sides, they would go away. So now I have negative 1 equals 4 minus 4 secant 3x. Let's go ahead and subtract 4 from both sides. And I get negative 5 equals negative 4 secant of 3x. And when I have two negatives, I can make those into positives. And that looks a lot more usable. But we still have a 4 in front of the secant. So let's divide both sides by 4. And that gives me something a whole lot better to look at. And let's pull a bunch of this junk out of my way and pull that up. And let's clean it up by writing secant of 3x equals 5 over 4. Okay, so just switched them around and kind of cleaned it up. Alright, so again, we don't like working with secants, we like working with sines and cosines. So we're going to write secant as that, and write that. And then if I cross multiply, I get cosine 3x 5 equals 4. Divide by 5 goes away. Cosine of 3x equals 4 over 5. There we go. That looks a lot better. Okay, so this is all I'm worried about you getting for an answer. I'm not really concerned in this section about what the book is asking for, because the book is asking for what angle times 3, where you take the cosine of it, is going to give you 4 over 5. Which, if you look at this, you're going to get adjacent is 5, I'm sorry, the adjacent is going to be 4, the hypotenuse is going to be 5, and then that is going to be 3. So it'll be a 3, 4, 5 angle. Alright, but what angle is this going to be in order for that to be true? 3 times an angle is going to give you this 3, 4, 5 angle. So you could take the arc cosine of 4/5, and it would give you that angle, and then you would divide it by this 3 to give you what your x is. So your cosine, or your arc cosine of 4/5, let's see if we can find out what that is. 4 divided by 5, and we're going to take the arc cosine, and it's about a 36.87 degree angle. So that angle is what 3x is. So if I divide that by 3, that's going to give me a 12.3 degree angle. So see how that works? This angle, this ratio right here is the 3x, the cosine of 3x. So the angle times the 3, take the cosine of that, is going to give you 4/5. So if you get that much of it, I'm going to feel pretty good about it. So that's it for lesson 6.3. We have one more lesson to do, and we are done with chapter 6, which is the worst chapter in the book. And the rest of the lessons get a lot more simple. So look forward to that.